Hello, today we'll be looking at problems where we solve angular velocity problems. All right, so our first example, it says, if a ball is traveling in a circle of diameter 10 meters with a velocity of 20 meters per second, find the angular velocity of the ball. So here, this is a pretty good depiction of a circle here, and here's a ball. Or pretend like this is a ball here, and it's moving in this circular path. So it's moving in this circular path. The diameter of my circle, so that means from one end to the other, is 10 meters. I want to find out what the velocity is. So if you recall from the lesson, we're given, sorry about that. We're given the formula of angular velocity is equal to the velocity over the radius. Well, lucky for us, that's everything that they've given us. We were given a velocity of 10 meters per second and a radius of, well, this says 10 meters. That's the diameter. So the radius is exactly 1/2 of that. So that's going to be 5 meters. And I get that to be 4 hertz. Okay. So let's go on to the next one. The next example. Oops, I forgot to erase that. So it says, suppose a car tire rotates 8 times a second. The tire has a diameter of 8 inches. Find the angular velocity in radians per second. So this is the formula in the lesson that we were given. We were given that the angular velocity is equal to the angle degree measurement, or theta, divided by time. We don't have that information here. So let's try to derive a different formula. So we know another way of saying the angle is equal to S, which is known as the arc length, divided by R, which is my radius. Okay. So just for recalling, arc length is equal to 2 pi r. So if I put this here, I get my angle measurement is equal to 2 pi r divided by r. So my radius is canceled out, and I'm left with just 2 pi. So that's what my angle measurement we would put here will be 2 pi divided by time. So we don't have time, so we have 8 times a second. So another way to denote this would be frequency. So frequency is in revolutions per second when we're dealing with angular velocity. So I can put this, and this is actually time is per frequency. So my new formula that I can use is angular velocity is equal to 2 pi times the frequency. And so notice when I use this formula, the only thing that I need is the frequency, which is 8 times per second, because that's revolutions per second. So I get 2 pi times 8, which is 16 pi. Let's look at one more example. All right, it says, what is the angular velocity of a spinning top if it travels pi radians in 1/3 of a second? Okay, so again, we're given, or we know that the formula for angular velocity is my degrees divided by time. All right, so we know, and time is in seconds. So we know that my degrees, or my angle measurement, is pi. They give us pi. And the time that we're given is 1/3 second. So 1/3 second, if I multiply this out, will actually turn to pi times, if I divide this, it would be pi. I'll change this to multiplication and change this to 3. And so I get 3 pi. All right, let's do one more example. So it says a 20-inch diameter tire on a car makes 9.3 revolutions per second. Find the angular speed of the car. Another really easy one. So this information here, I don't even need it, right? Because we know angular velocity, when we have the frequency, is just 2 pi frequency. And I know that I have the frequency because it says 9.3 revolutions per second. So sorry that this looks like a W, but just bear with me. I'm sorry. Times 9.3, which is 18.6 pi. And I hope that this helps.